Well, thanks for stopping by. Today is about developers. They're being asked to accept more responsibility as they build and test and run their code. But wait a minute, what's the role of the security team? Today, we look for the balance between dev and sec. We view the problem from several angles: the individual developer, their whole team, the security team, and the attacking adversary. We highlight some helpful tools and frameworks along the way. Welcome to Threat Actions This Week, the show where we look at the latest threats, tech, and actions your organization can take. Today's top security talent share their insights with you. My three guests this week are frequent speakers and prolific writers on Dev, Sec, and Ops. Starting with Maya Kaczorowski. She's the product manager, security, and privacy at Google, which means she covers off everything from containers to Kubernetes to GCP encryption. Joining us from San Francisco today, thanks for being with us, Maya.
Thanks for having me.
A little farther down the coast in San Diego, Shannon Leitz is the founder of DevSecOps Foundation. She leads DevSecOps at Intuit. Thanks for joining, Shannon.
Thanks for having me here.
And Larry Maccheroni. He penned the DevSecOps Manifesto. He's the Senior Director, Security and Privacy at Comcast. He's on the other side of the nation in Philadelphia. I appreciate the time, Larry.
Glad to be here. Thanks for having me, David.
So, Shannon, when you ask developers, how many adversaries do you have? How do you find they react to that question?
It's interesting because when we first started asking that question, it was kind of provocative on purpose. And it was surprising to many of them that we'd even ask as security professionals, because in their minds, it was our job. And as we've seen DevOps take off and we've seen more and more friction from, how traditional security was run, the notion that security was anyone else's job than a developer or a maker or a creator was really just foreign. I think the security professionals have realized that we have to find ways to create value for our new customers and also their customers. And that's kind of how we've thought about it. But I think it was a shock and awe, a little bit surprising. And what was interesting was there were several, and I think this was a shock for me, there were several development groups that actually had an answer. They knew exactly how many adversaries they had. They knew some of the TTPs they were using, which is techniques, tactics, and procedures. And so what was kind of interesting by being provocative is that we got back a different answer than we expected.
That is impressive. And it's really good to see that that's changing to that degree. Okay, so Larry, how far should we go here? Do developers need to go get their CISSP certification? How much security pro capabilities does the average developer need?
I'm actually not a huge fan of that certification. That organization has another one that's supposedly focused on developers, secure development lifecycle. And I've actually sat through that course, passed that test, gotten the endorsement for it. But I actually don't think it really prepares developers for doing the right job. I prefer an online interactive coaching approach. So there's a tool that we use. It's code bashing. It's by Checkmarks. And we're requiring all developers, including contractors, to actually sit through a 3 or 4 hour session in code bashing now. Basically what it does is you allow the developer to pick their programming environment, and then it gives them a list of exercises. And the exercises essentially first show them vulnerable code. Then it coaches them through actually exploiting that code. And that's really where the light bulb goes off. And I think this is similar to what Shannon has been talking about for a while now, is that idea of being attacked and seeing how easy it is to attack code that a developer would normally have written before this lesson is where the light bulb really goes off. And then, of course, it coaches you through modifying the code to prevent the vulnerability, to remove the vulnerability from the code. And you go through 20 or so of these lessons and you pretty much have a good feel for secure coding.
Maya, another component to this is the security pro themselves and their skill set. So should the security pro be learning coding and be able to speak the language of the developers to meet them halfway or 1/3 the way?
Yeah, I think what you said, kind of meeting it halfway makes a lot of sense, right? It makes a lot of sense for developers to understand security basics and likewise for security professionals still understand development basics and what's going on in that environment. But what I'm seeing that concerns me sometimes is when you have a security team that is completely unaware of what the developers are doing. I wouldn't necessarily put the blame on the security team. I think it's all around. But speaking of something like Kubernetes, I'm always shocked when a security team is like, oh yeah, some part of the org is using Kubernetes and they didn't tell us and now I have to secure it. That kind of interaction shouldn't be, throwing something over the fence. There should be a lot more upfront security reviews, code reviews, requirements reviews to figure out how do we actually make this work in our environment? What are the things that we're going to be changed on both sides for this to be successful?
One of the challenges here is that we're asking the developer to do more, right? And so their reticence is understandable if we consider their core metrics. So if we think about work in process and we think about throughput, I feel like security and speed are almost at odds with each other, that I can do it fast or I can do it well. And so, Larry, from your perspective, does security hurt my numbers as a developer, or can I throw bug fixes up on my Kanban board?
Of course you can throw and should put your bug fixes on your backlog or your ready column in your Kanban board. The question is whether or not you're motivated to do that. And so I like to take this ownership idea. I consider DevOps and DevSecOps just development teams taking ownership of how their product behaves in production. So imagine a developer getting called in on a Saturday. Previously, the ops guys or the security guys would handle the incident. But he gets called in on Saturday. He has to spend all Saturday working on this thing. On Monday, when he goes into his development team's planning meeting, he's going to say, if we'd had this one more piece of information in the log or this lever in the product to turn off the bad behavior and let the good behavior continue, then I could have been in and out of there in 5 minutes. And somebody else on the team will say, ops has been asking for those very two same features for years now. Well, now let's do them because now we're responsible. So I think right now there's a big separation between the person making the decision to put their hand on the hot plate and the person feeling the pain of the hand being on the hot plate. So the developers are making the decision to write code a certain way and prioritize features, but the security folks are the ones who are feeling the pain. I think we need to shift the pain to the developers, to the people who are making the decision to put their hand on the hot plate so that they're more motivated to give this the attention it needs.
So Shannon, when you look at it from your team standpoint, how do you help them to balance the extra work that they continue to need to do from a security standpoint versus the core metrics that they're going to have from a dev perspective as well? Or have they become one? What does that look like?
In our environment, it's actually become more united. So we have this thing called security defect reporting, which basically reports security issues into the backlog of developers. And so developers are able to see things coming, be able to prioritize them. We're in the process of really taking that to the next level and making it so that the teams can scale more. We've had a lot of security features that have been put into backlogs by the teams directly. And now as part of security defect reporting, we're kind of notching that up and have realized that as we build run books against our specific adversaries, that we need to be able to make it so that features are also characterized in a very similar way. So I would say what we've really kind of gotten to is that we want developers to be empowered to pull security features off the shelf that are consistent with what we're expecting, and then we're enforcing based on what we're expecting. Instead of the way traditional security has worked, which has been relatively punitive in a way. I think what we're looking to continue to foster is what we've done manually, which is to put those security features into the backlogs earlier, but also now really up level with more automation and forecasting. One of the cool things about really focusing and being adversary obsessed is being able to forecast adversary traffic, getting ahead of it, being able to look at something and say, yeah, this is, in 2 weeks, this is what we're going to see from this particular set of adversaries is, I think, relatively sexy work for the security team. And then as we're thinking about developers being our customers, what are we helping them to do? How much time are we cutting down in their backlog for security issues? And just how much are we helping them to stay ahead of adversaries for their specific workloads?
Ooh, and I want to come back to some of those points and pull on some of those threads when we think about the attacker's point of view. And so if I think about build and test and run, or maybe plan, build, and test and run. Maya, when we're asking the developer to look across their complete environment, is there certain areas they should be more focused on?
I think what changes with containers is actually a fundamentally different security model for that whole environment. So you're looking at, originally going from changing individual lines of code when you want to deploy changes in your application to changing whole containers. So instead of changing a single line of code, you're rebuilding the container, redeploying the container every single time. Well, that gives you something actually much more powerful from a security point of view than what you had with a traditional application development, in that you have a single place where you can enforce what gets deployed in your environment, do things like patching, because I can just apply a patch and then the next time I happen to redeploy, just redeploy that thing. So your build process might not necessarily change. Your test process might not necessarily change, but the way that they kind of all work together and flow naturally together does change.
Thinking about it, let's say from the NIST cybersecurity framework, and I've got, identify, protect, detect, respond, and recover. I get that identify, for sure, the developer has to understand threat modeling and starting to understand where to look in their code, and protect should be aspects that they're going to share with the security pro. When I start to get into detect and to respond, is that also in the developer's purview?
In my opinion, not necessarily. I think developers should follow kind of defaults and things like that a security team sets. So for example, if you're using a particular deployment management tool, always using that tool will help the security team figure out what's actually been deployed because they have a single source of truth they can go look at. But that being said, even the identify bit that you're describing, right? If I build my build pipeline in such a way that I actually am looking at everything that I'm deploying, because I can do that with containers every time a new image gets deployed, I don't actually need my developers to do anything. I can just look passively at what's getting deployed, and that tells me what's in my environment.
I'm with Maya on this pretty much exactly. I think that there's enough right now for developers to take on earlier in the pipeline that I don't think they should be focused on picking up the detect and respond aspects too much, other than, as Maya suggested, making it easier for folks who are focused on that to really participate. I would caveat it just a little bit by saying that to the extent that a development team is a fully empowered engineering team, including their own detect and respond capability, then I think it's in the purview of that engineering team. And I'd much rather that be co-located with the developers, and consider that all one empowered engineering team, rather than that have be thrown over the wall to a centralized security specialist group. So that's just a preference, though. I don't feel too strongly about that. But if the team is drifting that way anyway with their ops aspects, then I certainly would encourage them to do so as well with the security aspects.
It's incredible how many different areas of security there really are that someone could spend a lifetime learning. And so things like data classification, account provisioning, key management, code analysis, vulnerability management, session management, monitoring, data loss prevention, incident response, and on it goes. So that's great to hear that, Larry, you and Maya are both saying, look, there's only so much that you can know. And there's certain areas that, of course, you're going to be relying on the security pros within your organization, and they're going to be part of your team as well. So it's about creating the right balance in that team. And so, Larry, in just a minute, I want to come back to that point about what makes a team work well together. And you spent a lot of time there. Before we go there, I want to come back, Shannon, to the thread that you were starting to pull on, and that's looking at where adversary interest is going to be in your applications, and how can I create friction for the attacker in areas of highest interest. So can you shed a little bit more light on that? Because you've got some great findings there from the teams that you've worked with.
I think that when a development group has the right scope for their application and they have true understanding of who their ideal victims are, it's really easy then to identify adversary interest and start to pull apart adversary transactions, understanding motive, method, opportunity, understanding attack surface. So if you build an application, as an example, that has specific ideal victims associated with it, and you're taking that into account with your design, you're making more friction happen for the adversaries that might actually attack those ideal victims. And I think that that's kind of the crux of being a maker who has their customer in mind, being customer obsessed. We've heard a lot of that over the last 10 years, the last decade. is customer obsession is really a big priority for many makers. And so I think the twist to the customer obsession is 99% of your customers, it's easy peasy. But as a maker, understanding where an adversary might go is really about what you designed, figuring out how you're going to continue to support the maintenance work associated with your application, taking responsibility for that, and truly driving down the possibility of abuse by understanding what an adversary could do and to whom. And so that comes in the form of things like customer care logs and information there. It comes from understanding how you're dealing with your customer application and what they're trying to accomplish through it, and whether or not that's actually interesting to an adversary is up to their means and their capabilities. So what we found is that if you have a security team that takes that on, they miss the opportunities of context associated with what a maker has.
Very interesting. So the developer has insights simply that the security team, is not going to have. And one of the areas that you've spoken about before and written about in the past is the importance of the developer understanding and learning the kill chain. Can you talk a little bit more about how you work with your developer team to get them familiarized with the MITRE ATT&CK framework or with Lockheed Martin kill chain?
Well, I think that what we've really tried to strive for is proving that something's exploitable has a serious return on building more resilient software. And so we sort of raised the bar on our security professionals to have them build higher end testing skills so that we got past the theoretical observations and really helped developers to understand when they were putting priority to the things that needed to get fixed, it was more than compliance. And so if the way that we had to do that was we had to find a unifying framework that was easy enough. So everything we were looking at had hundreds of pages. It was complicated. It took years for us to learn. We all looked at it and said, yeah, that's great. That's just too much overload and too much context. That's the kind of stuff that we should be really good at. But how do we get our developers to be able to scale security? And that's when we looked at things like kill chain. Do we use Lockheed's kill chain? I think we've adapted Lockheed's kill chain. It's not quite their kill chain. It's a little bit of an adaptation. But I think that what we've been successful at doing is getting our executives to even speak kill chain. What is truly important to fix now versus what is the tail that we're worried about, and really having a focus that's got a unified voice across our organization is critical. I think you get that from frameworks that are easy to use, that have a common language, that really bear down on the most important things, as opposed to what that list that you rattled off earlier. Even a security professional has a challenge trying to understand all those things and be good at every single one. And that's why we have so many specializations. But as a developer, what you have to be able to take advantage of is that you're a generalist now in security that has to be able to really understand who are you talking to, what kinds of things can they provide to you, and how do you make the decision about what good looks like.
To kind of continue on what Shannon was just saying, I think part of it's just knowing what your threats really are. So if I think about what the most critical information that we hold is, and at Google, that's customer information. That's the thing that we protect the most dearly. You start looking at any way that somebody could access customer data. If that means SSHing to a machine, if that means pushing bad code, if that means a web vulnerability, whatever it happens to be, you start to prioritize those based on how much data can they get, how quickly can they get to that data, do we have measures in place to protect them, et cetera. So in terms of prioritizing different parts of the stack, I don't think that there's anything that you force more than something else, but you do have to remember that if your VM is vulnerable, it doesn't matter that your container is, in the best configuration possible, and your application has the best configuration possible, because the underlying infrastructure is vulnerable. Likewise, if you have the best detection tools ever, but you don't have any good configurations and defaults put in place, then you're only going to find the stuff that ends up in your environment, which is not great either. It'd be great to prevent some of that from happening. It's always like the risk reward trade-off. How much more am I willing to put in? Because you can always do more work in security. But that's not a problem to find work.
What are some of the tools that you recommend to developers to start to look at? I mean, there's so many. And automation clearly is going to be an important component of how a developer is able to be successful. What tools might you direct them towards?
For me, obviously having your SIM and your whole security pipeline and all that kind of set up. I think for me, the biggest thing that makes a difference from the get-go is, like I said, having good configurations in place. And depending what environment you're using, what development environment you're using, either something you can build in to the environment. So if you're using Kubernetes, there's a bunch of things you can turn on and off. Or your cloud provider, there's a bunch of switches you can turn on and off. But I see a lot of companies putting this in their deployment manager. So whatever deployment system you're using, if it can handle security configurations of different kinds, Terraform, templates, Chef, recipes, whatever it happens to be, Jenkins that you use, having some good defaults put in there from the beginning goes a long way.
Are there any special tools, Shannon, that you and your team tend to rely on?
We have done a lot of work integrating things like check marks and signal sciences. I can't stress enough that RASP has really been a game changer. I think the other ones, Splunk, honestly, was one of the pioneering foundations for our organization doing things like deception and also detection engineering. We have this principle, which is protection is ideal, but detection's a must. And so some of your protection principles are based on the speed at which you can detect something so that you can get to it fast enough, really trying to lock down the environment. The other thing I would say is we've invested in new tech because as you're transitioning to DevOps and things like that, you really do have to find partners that are trying to settle this space because emerging tech is very challenging. So I think what a couple of the other ones, elusive, port shift, some of those are really critical. If you've seen shift left at all, that's also very interesting. Some of those technologies have a lot of promise when it comes to really being more developer friendly, because I think that some of the security technology is still got such a high bar associated with it to be used by a developer that it makes it challenging for it to be part of the CI/CD without a security professional involved in the actual integration and usage.
We're asking them to learn about security concepts and then, hey, by the way, also learn some new tools as well.
And the other thing I think that's interesting too is like we use Qualys, Nessus, Nexpose. I probably could list every scanner out there. But one of the things that we also found is like putting the security professional in between the tool and the developer and really weeding out those false positives and having context around security problems and doing the prioritization has had a meaningful impact on the ability for our organization to really get ahead of attackers.
So Larry, you've measured dev team success and you've done some deep research there with a lot of data points. You found that there's some hard skills that I need, but you also found that there's some squishy, warm and fuzzy variables that make a big difference in terms of the success of a team. What does the optimal team start to look like from your standpoint?
Just to give folks who, unlike you, David, who might not know a little bit of background, I was at Rally Software for 5 years, and I was there as the director of analytics and research. My role there was to essentially crawl through the data of the tens of thousands of teams they had in their one multi-tenant SaaS stack database and try to correlate practices or sort of behaviors with outcomes, with performance. And so that research went on for 5 years, and pretty early on, maybe about year 2 in that research, we quickly discovered that the softer, squishier social safety factors actually have a tremendously large impact on the performance of a team, more so than we would have expected. Rally is an agile software product. They wanted all the agile practices to be the ones that had the biggest impact. And some of those did, but the social safety factors were much more influential than we ever thought they would be. So I became a student of social psychology, particularly of developers and development teams. And I learned a lot there. And one of the things that I've sort of evolved out of this is a useful tool for folks trying to work with development teams or even to improve the social safety factors on a development team is this thing I call the trust formula. And so the trust formula is credibility, how well you know what you're talking about, plus reliability, how often you actually do what you say you're going to do, plus empathy, how much you show you care about the other person's perspective. All of that is in the numerator, and divide all of that by apparent self-interest. So how much does it look like why I'm communicating you is for my benefit as opposed to for our shared benefit or for your benefit? And you always have some self-interest or you wouldn't be engaged, but you want that to be minimal. If the denominator is small, then the large numbers in the numerator sort of equal that out. And I've actually been able to coach both within a team and actually more effectively even now coach security specialist groups and how to communicate with developer teams by having them consciously think about how they can increase the things in the numerator and decrease the thing in the denominator of that trust formula.
Shannon, when you look at your teams and you've looked at what's worked and what hasn't worked in teams, how does that reconcile with some of the things that you've seen?
The teams that I've put together, what's interesting is I've pretty much tried everything, or so I think. Maybe it's 90+%. I think what I've found is that we've tried the embedded models where we've put security professionals into development teams, and depending on their needs, you could never fit one security professional into a development team and have that be successful because, as you have alluded to, there's a lot of different specialties associated with security. So I think that was challenging. I think the other thing that was challenging from an expectations perspective is when you embed somebody into a development team and they start coming up with these security constraints and requirements that cause a builder, a maker to be constrained in a way that made it so they could be less creative, that caused that person to almost be at the outcast, if you will. So that's very challenging. And then the counter is true, bringing developers into the security space, trying to introduce them in to learn about security when they want to make, and then you have a set of breakers, just uniting and getting people to a common goal and mission can be challenging because everybody's got sort of the things that keep them happy and excited about what they do and passionate. The things that have worked for us, I think, is really about how do you get a team to be a team? And how do you align mission with the goals of the company, getting folks to be really well aligned? And so as we've done that and we've focused on things like KPI to goals, making SMART goals, getting foundations and rigor in place, and also tying that to DevOps concepts, what we've found is that work is way more meaningful and rewarding, and we do better at getting rid of adversarial opportunities.
Well, thank you for that. As we start to look forward, Maya, and look into the future, you've got this incredible purview of what folk are doing with Kubernetes and with containers. And at the same time, Google has this incredible prowess from a machine learning and AI perspective. Are you excited about the future and what some of the potential capabilities are that the good guys might be able to bring to bear?
Yeah, I'm incredibly positive looking forward. I think there's a lot of exciting things that are going to happen in the future. I like to joke that Google is really good at containers and really good at ML and really good at security. We should be really, really good at securing ML running on top of containers. and we're getting there. We're getting there as a thing that we're working on out in the open and getting people excited about. But ML for security has always been a bit of a weird topic. People are not necessarily believing that we can detect bad events accurately just using machine learning. And I do agree that you need incredibly good data and very good models to be able to detect what's happening. That being said, there are lots of things that ML can help with in security in terms of, like, for example, automated policy definition is something that ML does really well. Hey, you've never touched this resource before, and now you're touching this resource. So any kind of anomaly detection or policy definition works well. The future definitely is bright. I think the shift to containers, to serverless, to all that kind of stuff is exciting in that a lot of security professionals are going to have to learn something new, but we're not fundamentally doing anything from a security point of view that's significantly different, right? Like if you had an IDS IPS before for your VMs, you still need one for your containers and for your serverless and whatnot. If you had an identity management system, you still need an identity management system. If you had a firewall, you still need a firewall. Like the concepts translate very easily. I think we get more strength in terms of how your code is deployed and what kind of enforcement policies you can put in place, like I was mentioning before. And you get a lot more insight into your application, which lets you do things like use ML to better secure what you're running.
When we're talking about DevSecOps, that tends to come out is identity. And focusing on that is one of the key areas that developers should be learning more about. Shannon, I'll start with you. What do you think? Is that one of the key areas that developers should be learning more about?
I do think identity is really critical because I think as you get deeper into the applications, they sit on top of clouds and you're starting to really create and be customer obsessed. I think it's truly where you start to delineate good from bad. And I think as a developer, having a sense of what's bad and being able to tune it down in your application is a core responsibility. And I truly think if we were to focus a place for a developer, it would basically be identity. I think there's other things that we want them to do as well. We kind of have a security hierarchy of needs, of which authentication, not identity necessarily, but truly authentication. And we're doing that as a minimum is part of the core responsibilities of a developer.
one of the things I still hear to this day from developers and development teams when you talk to them is, why do I need to encrypt the traffic between two of my services? And why do I need to authenticate the one service, the one machine is actually the machine I think it is, when they're both behind the firewall? And I come back to them with the phrase that I didn't make this up. I heard this from somebody, that identity is the new perimeter, that we've essentially lost the perimeter. Thinking about behind the firewall and outside the firewall is almost harmful, I think, now. We should still try to protect things. At defense in depth, I'm a firm believer in. But for developers to rely upon that now, I think is dangerous. It's actually harmful. And I like to say, design your system as though every machine were running on the open internet. Now, we're not going to do it that way, but design it with that way in mind. Sort of like Chaos Monkey, design your Netflix services as if they could be shut down at any moment and this whole system needs to stay up. It sort of puts developers in a different mindset, and identity is the key. Machine-to-machine identity is that example there, but individual identity is also just as important.
And so, Maya, when you look at the usage of identity in GCP, have you seen some best practices or maybe some worst practices?
I think it depends what kind of identity you're talking about. If we're talking about service identity, like Larry was just alluding to, there's a lot of exciting work being done in this space. So what you were describing, having each service have a unique identity, having a strong identity that it uses to authenticate itself to other services. That's something we've been doing internally at Google for many years now. We have a system called ALTS in place, Application Layer Transport Security, and there's a white paper that describes exactly how we've done that. But there's a new project called Istio. It's a service mesh that gives services identity, does service-to-service brokering, does MTLS between services, lets you monitor network traffic and do network security controls and that kind of stuff. And that very much is what we see as the way of the future, right? You're going to build some services on many different kinds of architectures and many different kinds of places, like different clouds and on-prem and whatnot. And they all need to talk to each other, and they all need to be only able to talk to services that have the same level of trust and have a strong identity. And so something like Istio lets you do that. Is it something that people are seeing right now on our cloud? Not necessarily. Is that definitely the way of the future? Yes, that's where we're seeing people head.
We've covered so much ground today. We've looked at the cycle of build, test, and run. We've looked at the NIST cybersecurity framework and a kill chain and given all kinds of different tools and examples that developers can start to think about, and the optimized team as well. Maya Kaczorowski, how can people reach you, and what do you have coming up? Conferences you're going to be speaking at, publications you've got coming out soon?
You can find me on Twitter. We have to spell my name, so hopefully you can look at the podcast details to get that info.
For sure.
And I'll be talking at Google's next conference at the end of July about Kubernetes security and encryption at rest and in transit.
Sounds great. And Shannon Leet, how can people reach you?
Yeah, I'm going to be at several things in this fall. I'm working on a podcast in addition to what we're doing at DevSecOps.org. You can get me at DevSecOps on Twitter, and you're going to see some things at Does as well as All Day DevOps.
Larry Maccheroni, how can people reach you, and what do you have coming up?
Yeah, so LinkedIn is probably my best. I'm not a Twitter fan, so spell my name. There's very few Maccheronis out there, so you should be able to find me on LinkedIn and connect with me and send me a message if you want to talk. I'm actually working on a blog series right now with DevSecOpsDays.com. I'm a founding contributor to DevSecOpsDays.com around the trust algorithm. So please check that out.
Looking forward to that. And there you have it. Threat Actions this week, recorded June the 26th, 2018. I'm David Senf. See you again next week.